Hello, welcome to my presentation. I'm Joannis, and this is a macro talk about micro decisions. I'm an active server-side.swift developer. I co-created with Tanner the original Vapor 3 version and the original async library, and I'm also the creator of MongoKitten. I'm also a tutorial writer in Tim's team for a Wender League, and I wrote the Swift Neo and Swift Package Manager tutorials there. Today's topic is what is performance? Why does performance matter? Performance and security is going to be covered, and understanding performance. So what is performance? Many of you have a different view on what performance is. I think for some of you it means response times, others it means requests per second, but in general people like to refer to it as metrics. CPU footprint could also be a metric of performance. But everybody has a different vision of performance, and everybody will realize how slow a site is or whether it's slow in a different manner. So response times, for example, they will be found out by the users the first. When a response time is slow, the app will be loading slowly or their website will be loading slowly. This is going to be a burden to them. Request per second is something that usually matters to developers. It's a nice metric that doesn't usually mean much, in my opinion, and in many opinions. But for developers, for some reason, it's got this magic metric that seems to be the judgment whether a framework is good or bad. CPU footprint usually matters more to sysadmins. How many servers do we have to plug in before this thing actually runs? And then there is development time, which matters a lot to to management. And finally, reduce server costs, which is the combination of all the others combined, matters to finance and environment. So what about that security stuff? So security is a really important factor for many applications because, well, it's the definition between whether your application gets hacked or not, whether it's online or not, or whether your passwords get cracked or not when a hack occurs. Poor performance is an attack opportunity because weaker hashes, they accommodate poor performance. When your hash implementation is really slow, like the early days of Vapor's bcrypt were, you had to lower the bcrypt version to a lower level to accommodate the poor performance because creating a new account would take 30 seconds. So by using a faster hash implementation, you directly fight against the attackers of your potential, the password crackers of your application that found your hashes. Denial of service attacks are prevented by getting more performant opportunities with your database, being more efficient in the queries that you do or optimizing your data models. And memory footprints attacks can be avoided by being more efficient with memory or being more aware of how you use your memory. For example, rejecting large JSON blobs would be a good, where Joannis Wise brought me into the picture. I was creating a JSON library, and it had a memory attack where it would expand almost infinitely into memory before the application would crash. So these kinds of attacks can be avoided by being more performant. A couple of examples are, for example, the 30-second hash attacks, but also flooding a login route is a really easy way to attack many API services because it allows you to abuse the slow password hashing. So in the end, performance is everybody's interest. So it's up to us to fix performance the best way we can. But how? Well, to fix performance, you kind of have to understand what performance is. When is something performant? When is it not? So how do we understand performance? And first of all, what technology do we use to accommodate us with this? So let's use our technologies. And for many of you, this choice has already been made. We want a compiled language to get better response times, better requests per second, reduce server costs, CPU footprint is going to be reduced. So we want an asynchronous ecosystem, also to help resist denial of service attacks and further enhance our capability of handling many clients. So you might be wondering, right, we already have this. For many of you, that's ServerSide.swift with Swift Neo. So why does it matter, and how does it matter to use these kind of frameworks, and why? Well, I have this analogy for an asynchronous ecosystem like Swift, and I like to refer to applications as companies. So a company has many colleagues. They're kind of like a worker in a sense. And many of you that were in the early days of Vapor 3 might recognize this term. A worker is doing many tasks, handling many requests, handling many database operations, And really what a worker wants to do is focus on a single task. By focusing, you're going to be more efficient. So if we translate this to Swift Neo, we could refer to a worker as an event loop. An event loop is really just a thread, something like a process that's trying to do a lot of work. And hopping between tasks would be hopping between threads. You really don't want to hop between threads. You really don't want to reduce the attention for the task at hand. And communication would be necessary to accommodate many threads and locks. So when you're handling a single route in 5 threads, each thread needs to lock the data before it's being sent to the next thread, because accessing the data from 2 threads would cause a crash. So to fix our crashes, we're putting in logs, and to put in logs would mean more communication. More communication means a slower API. So maybe this helps you understand the vapor tree model. So then there is the architectural step. You've chosen your server-side Swift application, or maybe another language. You chose to use Swift Neo, maybe with Vapor or Kitura. And then you want to sit for the application and start building it out, right? Well, no, you need to architect your application first. Some of the design decisions will be hurting you in the long run, sometimes even just a few months after release. So an excuse you might all put up is, we're not at scale yet, right? You hopefully will be that scale, but you don't know whether you're going to be there yet. So why would I invest my effort and time into architecting an application while I could just be developing it? Well, when you will be that scale and you have 10,000 users logging on daily, that's when you're going to notice it. They're going to be in the simple stuff, like sending out a notification to a whole organization or a whole community of users. But then your first big customer attaches to your company, and your product is being used by a company of 10,000 users. Now a single notification is going to be sent to 10,000 users, and not the 500 it would be before. So really, architecture is, in my vision, the importance of data models, database queries, and API design. Database models is where most of it could be won. For me, I choose MongoDB because MongoDB allows me to get the database part on the same page as the application logic, and really be able to work through it as a developer rather than a database administrator. So the database queries, they are to be made after the data models, but the data models are to be made during the. They are usually made before the database queries, of course. So really, a problem will be occurring in many situations where you've decided upon your data models and then you start writing queries, but the problem is that you didn't think about the queries that you're going to do before you wrote the data model. So now when you run a realistic query that you run into a production scenario, the query is kind of slow because the data model didn't take your situation into account. It didn't take the business logic into account. So really, most of the problems that will be occurring are in the database. And I thought Intercom had a great example of how they handled this. They have a lot of slow Ruby APIs. I spoke with their CTO, and they really weren't worried about their slow Ruby APIs. They're synchronous. They're not optimized for heavy load as an application, but they're highly optimized. They highly optimize their databases to drain every bit of power out of their hardware. And they just replicated horizontally a lot of API nodes, and together they were capable of handling millions of users a day, maybe even billions of requests per day. So event loops are kind of like the same thing. Event loops are a small isolated ecosystem like an API, and a single Vapor process will have many event loops usually. And each event loop is highly optimized to do their work. And there are many event loops in your application, but you might have many applications who are consistent of many event loops. So together they're capable of handling the load. But then we still didn't solve our problem. We're using Vapor and we're accommodating our performance issues. But really we need to be looking a bit further behind the scenes, beyond our API. We're looking into the database. We need to minimize the load that we put upon our database because our single source of truth is under attack by many requests per second if you're having a larger application. So how do we need to be thinking consciously on how to maximize results, how to maximize the amount of data that we can get from the database with minimal amount of effort put into it by the database hardware. So what I like to do is I like to separate the database concerns from client concerns. I think it's preferable to do 3 queries to a database and have the client or API handle the work rather than having everything put up by the DB. If the database is going to be under attack by questions like what is the result of adding these 2 values, it's still going to be processing power that the database is wasting. Well, you could just be doing that simple calculation in your code, but you're maybe too lazy or maybe blindsided to do so. So really, we want to be reducing communication between the database between the database and client, but we also need to be conscious of where the database puts its effort. So for me, I like to start with the data model, like everybody. And one of the first easy things to take away when you're working on your data model, especially in SQL world, is not to use auto-incrementing IDs. When you're auto-incrementing ID, it's basically a counter that's going up every time you create a new record. And creating this ID in general means locking the integer that is counting up, and after it's locked, you take the value, you increment it, and then the next thread can take the next value. But if you take a lot of IDs out per second, the limitation is going to be the single thread that's going to be responsible for updating this ID. So really, you want to be using MongoDB's object ID or a UUID in the case of MySQL or PostgreSQL. In MongoDB, I have some special tricks that I like to use. For example, they support arrays. Arrays are a very powerful tool that some databases like MySQL, but also I think PostgreSQL, don't really support in a way I think they should be respected. Also, MongoDB allows you to group nested structures of data, something PostgreSQL I think is also partially capable of. So what I like to do is, for example, create a user profile with a private section for my password and my private information. So whenever I access my database and I want to give my profile to a random user, I select every field except the private parts. And when the private parts are omitted, then everything else can be just sent to the client. And this allows me to keep it a very lightweight operation to remove unnecessary parts from the data model and keep the API with the least concerned with these operations. I also try to look at the database queries. I also like to look at the database queries and see how would they think about this query. Like, what would they need to do, the database as an application, what would it need to do to give me the information? I'm a bit conscious about that. So for example, I select all fields from the profile from the user I want to return, except the profile but not private, and then I just return the profile from the DB. So at this point, there is no step 3, I'm already done. Even my API logic is a bit reduced. So on both sides, I'm cutting corners, right? I'm cutting off situations and processing power that I need to do. But another situation which I'm really happy with is whenever I have a user system like a social app, I might be wanting to block any of you from here in the hall from my chat. So we're having a chat on an application, and suddenly we're having a furious conversation, maybe even like an angry conversation, right? And I'm quite angry at you, so I want to block you. But now I need to create a new relation whenever you tap the button, and every time your profile or anyone's profile in the application is brought up, I need to look through the entire table for whoever I block, but also which of the persons blocked me. So now this is a situation where I don't want to be in, because I need to be querying this table every time I'm asking for a user, which is quite a heavy operation. So what I like to do is I create an array with blocked user IDs. So I'm loading the user profile, my current user profile, and I'm asking the database for all the users that are in my friends list, or that maybe used to be in my friends list. But I can exclude everyone whose ID is in my array, but also I can exclude their profiles if I'm in their array. So the query is contained in a single collection, which reduces the amount of steps that the application needs to do to go from a problem, like a question, give me the list of friends, to a solution. So another thing I really like to think is important outside of databases is API design. When you're designing your API, one of the first things you're doing is just making it public, right? You want your app to connect to the database. You want your app to connect to the API, because the API is responsible for giving you the data from the database. So you need to allow your application to be deprecated whenever you're upgrading to a new version. And to do so, by doing so, you plan room for optimizations. So maybe the previous algorithm that gave you a list of chats, maybe it wasn't ideal, maybe it gave a bit too much information, it wasn't even necessary, and all these computational costs, they're wasted, and we could probably find a more efficient solution or split it up into 2 routes. So the only solution would be to deprecate the app, but you didn't bake it in. So so one of the first things I like to do when I work on a new app is I want to be able to force an app update. And when everything is put together in the architecture, that's when you end up at development. And when you're developing, you want to be conscious about performance, but you also want to not break your back over it, because management has a way of finding you. They're responsible for your paycheck, and they want the product delivered. So that's the last bit of performance that we're going to be covering. And that's, that's it. Sorry, I think I'm missing the next slide. I only had 2 more slides anyways, but I'm missing the ending slides. That's it.